Okay, let us continue, everyone. Remember that if we have a right triangle, the Pythagorean theorem says c squared is equal to a squared plus b squared. Let's take a look at this example. This example says, hey, verify that. Let me follow the example in the notes. The points that are given to us as 2 and 1, 4 and 0, 5 and 7 are the vertices of a right triangle. Vertices of a right triangle. Very good. So, since we learned something new today, we want to apply Pythagorean theorem and try to verify it that way. If I try to visualize this, it's going to be like this. So I have my x-axis, I have my y-axis, I have 2 and 1, 2 and 1. The next point 4 and 0, 4 and 0. The next point 5 and 7. So 1, 2, 3, 4, 5, 6, and 7. So 5 and 7 is just right here. I'm trying to find a relation between these sides and show that I have a right triangle. I'm going to apply Pythagorean theorem. So this point is 5 and 7. This point is 4 and 0. And this point is 2 and 1. What I'm going to do, I'm going to find the distance between these points. Let us find the distance between these points. So the distance between 2 and 1 and 4 and 0. Remember the distance formula. If you have 2 points, x1, y1, x2 and y2, the distance says, hey, you need to have the square root of the difference between x values to the second plus the difference between y values to the second, all inside the radical. So this is my x1, this is my y1, this is my x2, and this is y2. The order is not important, guys. You might say, hey, this is my x1, this is my y1, this is my x2, and this is my y2. So here, the distance between these 2 points is equal to square root of, well, here you have 4 minus 2 to the second plus 0 minus 1 to the second, which is equal to square root of. Here you get 2 squared plus negative 1 squared, which is equal to square root of 4 plus 1 or square root of 5. This is this distance here. Let us find distance between 4, 0 and 5, 7. 4, 0, 5, and 7. Now this is your x1, this is y1, this is x2, and this is y2. So this distance is equal to square root of 5 minus 4 to the second plus 7 minus 0 to the second, which is equal to square root of, you have 1 to the second power plus 7 to the second power, which becomes 1 plus 49 or square root of 50. Very good. So let us move on and find the distance between 2, 1, 5, and 7. 2, 1, 5, and 7. This distance is equal to square root of, okay, this is my x1, y1, x2, and y2. Difference between x values, 5 minus 2 to the second, plus difference between y values, 7 minus 1 to the second. Okay, this guy is equal to square root of 3 to the second plus 6 to the second power, which is equal to square root of 9 plus 36, or you get square root of 45. Perfect. So what's the connection between these? It says c squared is equal to a squared plus b squared. Then you have a right triangle. Very good. The distance between 2, 1, 5, and 7 is square root of 45. This distance is square root of 5, and this distance is square root of 50. All right, very good. So square root of 50 to the second power, square root of 50 to the second power, is this equal to square root of 5 to the second plus square root of 45 to the second? This is left-hand side of the equation, and this is right-hand side of the equation. 2 as exponent and the square root, they get canceled out. So on the left-hand side, you have 50. Exponent 2 and the radical, they get canceled out. You have 5 plus, and finally, you have square root raised to second power, they get canceled out. You get 45. It says, hey, I have 50 on the left, on the right, I have 5 plus 45, which is obviously 50. So you have equality between these two. What's the meaning of that? It means that the Pythagorean theorem makes sense here. It means that we have a right triangle here. This is going to be your C. This is, for example, your A, and this is your B.